Okay, now we're going to review the periodic table and how to use it. So your essential question is to analyze how the periodic table is grouped and organized. You will be given a periodic table of elements. Make sure you ask me for one, and through this video you'll be able to label the periodic table, and you will use that in your practice. Okay, so our learning target 39, be able to use the periodic table to find parts of an atom, the atomic mass, the atomic number, and valence electrons. All right, so the first thing you're going to want to do is get the periodic table out, and you're going to want to have some colors because you are going to be shading in. So let's take a look at the information that you are given on the periodic table. So like I mentioned in the previous target, the atomic number is always the number located above the element symbol. Now, some of the element symbols, remember, some are different, like sodium, which is Na, and that's simply because it has Latin roots. The atomic number tells you the number of protons, and remember, protons determine what element it is. The atomic mass is the number of protons plus neutrons as a weighted average because it includes isotopes. That's located at the bottom. So let's take a look at our periodic table. If you notice, it is organized by increasing atomic numbers. 1, 2, 3, 4, 5, 6. So the periodic table that is the way it's organized, and it's organized in this way as you will start to see when we start looking at families. Okay. All right. So group 1A is known as the alkali metals. That is right here, 1A. Okay? Now, groups all have very similar properties, and they all have the same number of valence electrons. Okay? Group 1A is very reactive. That means they like to form compounds. They don't like to exist on their own. They like to buddy up. So you're never going to find them free in nature. So you're never going to find hydrogen all by itself. It's either going to be bonded with another hydrogen atom or most likely with an oxygen atom to form water. So these elements you're not going to find on their own. They're going to be in the form of compounds. That's why they're very reactive. Okay? And they react readily with water, especially sodium. Sodium will react with water and explode, cause an explosion. Group 2A is known as the alkaline earth metals. Oh, and I forgot to tell you, you're going to want to label these 1A, 2A, and you need a key on your periodic table, maybe somewhere down below where you're labeling alkali earth metals. You're going to label all the families on your periodic table because you are going to have to know the names of them. So group 2 is called the alkaline earth metal, or earth elements. They are all metals. Okay, notice group 1A is mostly metals except for hydrogen. Hydrogen's a non-metal. Okay, they occur only in compounds. So again, they're very reactive. You're going to, just like group 1, they react with oxygen, okay, to form a compound that is involved with oxygen. Okay, group 2A will usually always react with oxygen to form a compound. Okay, so group 1A is the alkaline. They are all metals except for hydrogen, which is a nonmetal. And remember the big difference between metals and nonmetals. Metals are usually solids at room temperature, with the exception of mercury down here, which is a liquid. Metals conduct electricity. Okay, nonmetals are usually gases at room temperature, and they do not conduct electricity very well. And then if you take a look at your alkaline earth elements, these are all metals. Okay, group 3A, let me go back to it. It's right here. Okay, this group right here, 3A. Those are called metalloids because they have properties of both a metal and a nonmetal. So they will somewhat conduct electricity. That's why they're used a lot in computer chips. Okay, it includes aluminum, which is the most abundant metal in the earth. And it forms oxygen compounds where X is the group 3A and usually forms a compound with 2 of the metalloids, 3 of the oxygen. Okay, I forgot to mention that up here with the alkaline earth metals. You usually just take 1 of the alkaline earth metals, like magnesium, and it will bond with 1 O, oxygen. Okay, group 4, and I'm just going across here. We'll get back to these elements in a minute. But group 4 includes metals and nonmetals. Goes from nonmetals at the top of the column to metals at the bottom. All oxygen form compounds, and it looks like this. 1 of those will bond with 2 of oxygen. Group 5A, all elements form oxygen or sulfur compound in this way. It'll either take 2 of group 5A bonding with 3 oxygen, or 2 of group 5A bonding with 3 sulfur atoms. Group 6A includes oxygen, one of the most abundant elements. Generally, oxygen compound formulas with this group are element and then 2 atoms of oxygen or 3 atoms of oxygen. Okay, so group 4, 5 are right in here. 6 is the one that includes the oxygen. 7 and 8 have certain names, so we'll get to those. Group 7 is called the halogens, which means they form salts. Okay, so these elements combine with the alkali metals to form salts. So if you take a look at your periodic table, these elements will combine with these elements to form salts. Like sodium, Na, bonds with chlorine to form sodium chloride, that's a salt. Lithium will bond with chlorine, lithium chloride is also a salt. Potassium, which is K, will form with chlorine and form a salt, potassium chloride. Okay, group 7, they are very reactive, so they like to form bonds. You will not find them by themselves either. Then you've got your last group. The last group was originally called inert gases because it was believed that they never bond and form compounds. But we have actually proven that to be false. So now they're just called the noble gases. They usually will be found in nature by themselves, but every once in a while you'll find them as compounds. So group A, they're the least reactive group. They're all gases, and they're not very abundant on Earth. I mean, we don't find them that often. Okay, and that's the name noble gas because they're not very reactive. Now, I will have that link underneath of the website that I was just going over with you. It'll be underneath the video. For those of you who are interested when we get into bonding and doing the electron cloud model, you guys can use that website as a guide. Otherwise, it's just there as a resource to go back and look at the groups, how the periodic table of elements is grouped. Okay, so what you're going to want to do is when you get your periodic table, you're going to want to color it based on this key down below. Okay, so nonmetals are going to be in green. Okay, then you're going to, so all metals are going to be green. The alkali metals are going to be kind of this orangey color. Transition metals are going to be in blue. The alkali earth metals, which is group 2, are going to be in kind of a turquoise color. Okay, rare earth metals, which are down below here, you can choose another color of blue. And then other metals, which include the metalloids, are going to be in purple. Halogens, which are gases, you're going to color kind of this tan color. And then the noble elements, which are gases as well, you're going to color in kind of a peach color. You can change that key coloring up. Just make sure you have this key or legend to help me know that you changed the colors up. Okay, the last thing I want to talk to you is about valence electrons. I want you to see these numbers in red. I want you to put these on your periodic table because these numbers represent the number of valence electrons, which is going to be really important when we start talking about bonding. So the alkali metals except for hydrogen, which is a nonmetal, have one valence electron available for bonding. So all of these will have one valence electron. When you go to group 2, which is the alkali earth metals, they will all have two valence electrons. Now, when you get to the transitional elements, they vary, and you'll learn how to figure out the valence electrons, so you can't use this easy system. So you skip over here, okay? This group has 3 valence electrons, 4, 5, 6, 7 valence electrons, and then 8. And this is why they are called the noble gases, because if they have 8 valence electrons, that means their outer energy level is full. It has all the electrons that it needs. So it does not need to bond with other atoms or other elements to gain or lose electrons. It's already got a full outer shell. That's why they're noble gases. The only exception to this one is helium, because helium only has 2 electrons. It only fills up that first energy level. It has 2 valence electrons, and it's full because it doesn't need more than 2. So these numbers in red represent the valence electrons. You want to add that to your key as well, okay, because you're going to use this periodic table when you get to your next section of notes on how to bond. Okay, so hopefully after you've colored in your periodic table and labeled it, okay, you will be able to find the parts of an atom. You'll know where the number of protons, electrons, and neutrons are located. You'll know the atomic mass of each element. You'll be able to tell me the atomic number of each element. And you'll be able to tell me the valence electrons of each element.